good afternoon, ladies and gentlemen. Today I'm very honored and presenting several research in our laboratory. And unfortunately, Professor Zhang cannot be here to make this presentation. And I'm Fei from National Engineering Laboratory in Beijing Jiaotong University. And today's talk is named Architecture and Technology for the Future Internet. Basically, there are four different parts in my talk. The first one is background and challenges. Before the background, I would like to propose several questions. The first one is why the traditional telecommunication company is seriously challenged by the internet. Okay? The second one, why the Internet Plus was proposed by the Chinese government. If we want to answer these two questions, we have to think more about the evolution of telecommunication and the internet. Right? I still remember about 6 years ago, in the Spring Festival Carnival in China, which is a big day, just like the Christmas in Western country. So people still talking about how many short message was sent through the cell phone. Okay? I clearly remember that was the last time people talking about that in the television. Right? Nowadays people use WeChat, we use so many different social networking apps, software via internet. Okay? Maybe this is one aspect. So telecommunication company was seriously challenged by the internet. Okay. For the second one, based on my perspective, I think Internet Plus is just a short for Internet Plus industry. Right? So Internet has been widely used in everywhere. We have to be focusing on specific area. So this might be the purpose of Internet Plus. So I would like to show you the essence of Internet culture. Okay? This is just one aspect of Internet culture. It's just so big. Right? It's just several representatives. The first one, open. Okay? Everybody can use the Internet for free. Right? And the second one, free, we can have two understandings. First one is not expensive. Right? Sometimes it's just complimentary. Right? Second one, freedom. Right? You didn't feel a lot of limitation when you use the internet. Right? Third one, fair. Previously, Professor Ma talking about IETF, which is short for Internet Technology, IETA, Internet Engineering Task Force. Right? Professor Xin Li is also the leader of this organization. If you are quite familiar with this organization, you can see even you were the chair of the group. If you want to say some personal, you have to go to the line and waiting in the queue. So this is kind of truth for showing the fair in the internet, right? And for the last one, pragmatic, I think this is quite obvious. And not only the internet, for the other kind of technology, we have to follow the circulation, right? We propose the technology, we do the validation, we put into the standardization process, then in the commercial, right? The only difference is the internet is much quicker than ever before, right? So if we compare with telecommunication and internet, for the first one, we have from 1G to 5G, right? Maybe the speed is one aspect, but if we use the similar standards to separate the current internet, from 32K, 64K, 1 mega, 10 mega, 100 mega. I have no idea how many generations we have in the internet, right? This is because in the internet, the target determination is quite difficult, right? Just because the demand and the requirement are always changing, which motivate the circulation very fast. So I think this kind of truth is the answer why the traditional telecommunication is challenged by the internet. The third one, why next generation internet is needed. At the very beginning, when the internet was created, people were quite simple, right? We are quite satisfied with sending the packet from the source to the destination, exchange some information, that's enough. Now we put so much burden to the internet, right? For example, for the mobile vehicle network, we have to face the situation wireless mobile in the large scale, reliable communication in real time, ubiquitous communication in high density. Right? And for the different industries, we have different requirements. This is true. Right? We have to face in the mobility, real-time, reliability, security, so many different problems. Which means multiple demands and multiple requirements of current internet are proposed. The question is how to solve it. Right? This is the background I want to share with you guys. Second one, the challenges. The original philosophy of current internet, when we designed it, just like I said, it's quite simple. But now we have so many problems. For example, for the resource utilization. Okay. Based on the latest statistics, for the backbone part, we only have 30% utilization ratio. Okay. For the accessor part, it's only 10%. Right? 1/10 time. This is we only use the internet in the access part, 1/10. For the energy consumption, okay, for the Chinese ICT, for each year, we are consuming the 30 billion kWh, which means 6 or 7 the capacity of Xiaolangbi power station. This is really huge, right? And user experience. We all know the current internet is based on the best effort mechanisms, which means I can try my best, but I never ever guarantee, right? In the IP layer. But this is not the requirement for the different applications. And for the fourth one, scalability. Nowadays, if you check with the core routers in the current internet, more than roughly 1 million items in terms of the routing table. Routing table is you receive a packet, you have to check with the routing table to determine which port actually to do the forwarding. This is really huge. We can imagine if we put IPv6 in it, what's going to happen? Can we support IPv6 if we add Internet of Things into the current internet? Okay, security. This is the old topic, right? It's still evolving, it's always evolving. Okay, the mobility. I just don't want to repeat all these kind of things. These questions actually give us a lot of considerations, which also prove that it's good timing to rethink about the new design for the future internet. Second one, the current research status. From 2006, we have seen so many different projects launched by the different organizations from the multiple countries, right? From the Fine Fair, FIA to the Horizontal 2020. Basically, there are two kinds of solutions. The first one, evolution. We just patching something on the current internet to make it better. The second one, clean slate. We design a brand new architecture for the future internet. In my personal opinion, I think we should try to build a brand new, but we have to guarantee that this kind of new innovations could be used in the current internet. I think this should be a good way to solve this problem. But unfortunately, so far we have not yet found any new network system and mechanism that can be used to solve the above-mentioned serious problems comprehensively and effectively. In China, we also focus on this significant field, right, which have been regarded as the most important and urgent core research area in 13th five-year plan. Right? Just in case you are not quite familiar with 973, this is the one of the most significant projects launched by the Chinese government, focusing on the high-tech area. Okay? For each year, normally 60 projects will be supported. Right? So we can see the future internet is very, very important. That is why a lot of project was launched. Okay, about the research status. I'm not quite sure whether you are familiar with NDN or CCN or ICN. This is kind of clean slate architecture for the future internet. Right? The problem is, if you think about the current internet, you want to see a movie, a fancy movie in YouTube. For some reason, there's something wrong with the DNS. DNS is the domain name system, right? In charge of changing your URL, www.youtube.com, to the IP address. For some reason, it's not working. Then we cannot see this fancy movie. The idea of NDN, ICN, or CCN is we don't care about the location of the content. Right? We don't care about the location of the content. We only care about whether I can find it. Okay? Or what is the resolution of this movie. Okay? So if we compare with NDN architecture and the traditional internet, we can see both of them are thin width, right? So if we imagine that internet can be evolved into this way, it's going to be great, right? I don't need to remember any website. I just want to ask the network to give me the content I want. Okay? This is the name of the movie. And the network will feedback me the movie, the content, the results automatically. So this is fantastic. Right? Actually, this is the target, one of the targets for the NDN, I see. So if we can achieve this goal, we say this is kind of content or service oriented. The traditional internet is host oriented. Right? We can enhance the user experience for sure. We can improve the network efficiency. But we also have a lot of problems. Right? Whether we can have the scalability, how much can we guarantee the security and mobility, right? And large-scale problem. I think in the IRTF, the latest progress in the ICN is people are focusing on put the ICN into IoT. I think this is a very good idea because IoT, sometimes the scale is smaller, right? Sometimes the scale is smaller. We can use ICN in this area for sure. And there are also several promising results in the IRTF. So if you are of interest to this, I suggest you to read more articles in this area. So SDN, I just don't want to repeat this. I think this morning you should be quite familiar with this area. If I use one sentence to describe, we just separate the controlling and the data. In the traditional network, we put them together. Right? So if we separate this, we can have more controllability, we can have more manageability, we can improve the network efficiency. And the problem is also very obvious. How can we get standardization? How to do the interoperability? How to trade off between the complications and the functions? Right? The third one, NFV, which is abbreviation for network function virtualization. In the traditional network, if you want to have one kind of function, you have to buy one equipment. But nowadays, people are quite familiar with, I only buy one thing, one hardware, and by using the different software, we can achieve the different functionalities. So this is the idea of NFV. So we can virtualize the network functions. We can simplify the network and services. We can save energy and expenses. Okay? And the problem is how to maintain your stability. How to reduce your complexity, how to deploy this one in the large scale. So we want to say, now we have so many different problems. It is very hard to find the root cause of the previous problem in the internet. And it's more challenging to solve them comprehensively, right? If I have one problem, I solve it by patching something. This is not easy, but it's not extremely hard. Right? So I think this is very challenging to solve them comprehensively. Okay, comprehensively. So it's extremely difficult to deploy the solution in dynamic and large scale. So research team and foundations, we want to solve this problem. We want to solve this problem. Actually, we create the IPv6 router, the access router in our laboratory, and we have some certifications, and we also got several awards. Second one, we proposed a 2-layer model and 4 identifiers, 3 mappings. This is the first 973 project in our laboratory. In 2008, all these kind of patterns was lessened to the ZTE for application. Right? So we separate the Council Internet into 2 different layers, and we name the 4 identifiers. By using the mapping mechanism, we can solve part of the problem. For these achievements, we had the first prize of Chinese Institute of Electronics Information, and the Ministry of Education, the first prize, the National Technology Invention in 2014. Okay, to sign up. This is the main part of this talk. Cyanide is the abbreviation for Smart Identifier-Based Network proposed by our laboratory based on 12.7-PM project. We want to clarify that all the previous problem, if we gave them 3 different routes, we can say, this is the problem with user and network, results and location, control and data. Okay? For the CCN, it's only focusing on how to separate the results and the location. Okay? I want to see a movie. I don't need to care about where is the location. I just want to get the content. That's enough. For the SDN or NF3, we separate the control and data. Okay? For the identifier-based network or the list, we just separate the identity and location. Identity means who I'm not. Location means where I'm not. Okay, we separate. But in the traditional network, IP address can contain 2 kinds of information. So, cyanide, we want to solve them simultaneously. Then we want to solve all these kind of problems comprehensively. So this is several demonstrations for why we have the problem. Because we combine identity and location together. If you move from one place to another, you have to change your IP address. All kinds of mobile IPv4, mobile IPv6, we just want to solve this problem. Okay? And try to avoid the triangle routing. The current solution we can use is or HIP. Address spoofing. I just use a fake IP address and send something to the destination. And the destination may think another guy is trying to communicate with it. Easy to attack. If I know one IP address for the core network, I just send a packet like crazy. Okay? I think everybody should be quite familiar with 12306, right? 12306.cn, right? So during the Spring Festival period, this is just kind of DDoS attack for this website, because everybody wants to buy the ticket to get home, right? So this is very easy to attack. And for the results location binding, whenever you want to visit somewhere, you have to ask the DNS, and DNS will give you the IP address so you can visit the server, which will trigger the network congestion, low resource utilization, bad user experience. The current solution is ICN, CCN in here. So control and data binding. In the traditional network, we are following the best effort slogan, which means I just forward the packet from the source to the destination. Use the shortest path. I don't care whether this path is heavy or low. Okay? In this case, it's quite obvious that if the packet is forwarded in the green path, it should be better. But we just can't do this. So current solution, we can use SDN and FTD overflow, etc. Design that architecture and the solution. Actually, this slide is not the original from our laboratory. I think this is kind of common idea for the future internet design. Okay? More and more people are quite agree with this kind of idea. Existing network is a static, inflexible, fixed. For the future network, it should be smarter, should be cloud-oriented, should be collaborative with the different elements. So, for the network equipment, we have to put a lot of modules inside, right? Components, virtualization, intelligence, security. We have to put a lot of features inside. For the core network, we have to separate something. We have to decouple something. Okay? For the hardware and software, we should decouple them. The situation is the same with the resource and the location. The first one. For the controlling and data, backbone and access, we should separate them. Right. This is the architecture proposed in the first 9.7.3 project, and this is the second one. We just add one more layer in the architecture. We have the smart services. We want to define a uniform, ubiquitous layer for handling the different kind of services. We want to have a smart network component layer to handle different forwarding. Imagine you have one application, you want to do the forwarding. I can form a specific group just for this application. If you finish your transformation, I can destroy them and use this kind of resource for the others. Okay, this is the idea. And we also construct the entity domain and behavior domain. I don't want to introduce this part. In one sentence, the cyanide is a data and cloud-oriented architecture. So by separating the user network, we can exchange from AID, which is identifier for the user, to the RID, the identifier for the network, to solve the mobility and the management issues. And we can also use this mechanism to handle the security, right? By using the cyanide, we can reduce the false alarm rate for the DDoS attack, and also the false negative rate, and this is the result. And this paper was published in IEEE network. So this is a mobility performance analysis for the cyanide. We can see that the latency was reduced. Seems that I don't have enough time. Okay. So this is just the similar idea with ICN. I just want to skip it. By using cyanide, we can reduce the forwarding time. By using the cyanide, we can construct a different family. Okay? If you need high bandwidth, I can give you more bandwidth. If you just want to browse the website, I can give you a low bandwidth family. So this is kind of comparison for the list, for the CCN, for SDN, for pursuit and cyanide. Okay, achievement and applications. This is a work published in Springer related with a promising design for future network. I think people can buy it online now. And this paper was published in IEEE Network magazine. And some papers published in transaction again, with communication again. Okay, and Professor Zhang also invited to do the keynote speech for several famous international conferences. Okay, so the general chair said request you to talk content from a large number of audience. More than 100 patents has been licensed to the ZTE, and I'm not sure whether this is the correct translation. 中兴通讯、神州高铁、北京新联铁啊。So the total amount is more than 35 million RMB. Okay, so this is kind of application for the SciNet. This is called Smart Land, and this is Smart WAN. I think this should be. 我这部分用中文说吧。Sorry 这个我们刚才介绍了一下这个SciNet是吧？一些基本原理啊，我们实际上就是想统筹的、一体化的去解决上述的一系列问题啊。那么我们把这个东西已经很多的专利转让给中兴通讯，转让给神州高铁。我们用在哪儿呢？比如说我们给时代集团，这个是我们国内第一家上市企业，它做电焊机的。这个电焊机大家都知道，早期的时候我们这个电焊机都有线，对不对？但是我们现在要焊东西已经不是过去那种情况了，我们必须要保证高可靠、高实时，同时在复杂场景下，对吧？那么用传统的 WiFi、ZigBee 蓝牙这些技术，可能它会受到一些限制。那比如说我要传这个包，要求它两个包之间的距离不能差0.5，不能差0.5秒，也就是500个毫秒，对吧？经常会有这种，所以用了我们这个SciNet技术，我们给它解决了一系列的问题。好，马上。然后这个是我们在深圳高铁上，我们大家都知道，现在上网在这个高铁上，我们不用说上网了，连打电话都很费劲。对吧？我们就可以在后台用这个SciNet的技术，协同的用多个网络，比如电信的、移动的、联通的，我们可以协同的去用，是吧？我们专门做了一个这个设备，在300公里的场景下，我们可以保证这一个车厢的人去上网没有问题，看视频一点都不卡，是吧？我们可以看到和华为的对比和这个瑞典的这个 ICOM 的对比，这个绿色代表的是 good performance。然后这个红色的代表的是 bad performance， 然后这个是我们给这个应急中心做的一套系统，也是基于我们这样一个多功能的SciNet路由器，后边可以是协同的去多张网去使用，在这种海啸啊，在这种洪水这种情况下，我们可以去保证它的视频是这个信息的传输。还有我们这个是给沈阳局做的一套系统，就是通过这个类似于谷歌眼镜的这个东西，我们可以摆脱这个监测人员的双手，他只需要把这个拍下来，就可以通过我们的设备就传走了，对吧？也是保证它的高带宽，这个是给西安铁路局做的这一套这个轮轴的检测系统。王老师就最后一段了，这个轮轴大家都知道我们每天这个高铁要跑，5天1小休，对吧？1个月1大修，实际上有的时候它压根就没坏，你也可能拉过去修，或者马上就要坏了，你还没修，对吧？所以我们通过我们这个SciNet的这个技术，可以用传感器实现什么呢？就预测修。通过传感器的节点，能够把它的一些状态给它采集上来，通过我们的这个多接入SciNet这个路由器，给它实时的高可靠的给传走。然后再依托这个SciNet在后台进行一个大数据的一个分析，所以这就是形成了一个闭环那么现在传统的网络，它做这个轮毂这点是怎么样？拍一张照片，这个数据量很大，它得拿 U 盘拷回去，这个效率非常的低。好，基本上就是这些。Thank you so much.